So today we're doing Newton's second law of motion. Remember that first law was inertia. An object at rest stays at rest. An object at motion stays at motion unless an outside force is acted upon it. So today we're doing the second law. The second law, really, most people think of it as F equals ma. What that means is the magnitude of the force is equal to the mass multiplied by the acceleration. F equals ma. So acceleration is produced yes, if I'm writing it down, you should probably write it down. When a force acts on a mass. Acceleration is produced when a force acts on a mass. So force. When we're talking about force, a lot of times they'll say net force. The net force is the sum of all the forces acting upon an object. So if you have a 5 Newton force to the left and a 2 Newton force to the right, your net force would be 3 newtons to the left. Because, notice I said newtons, the unit for force is a newton, which we show with an N, capital N. Mass. Is measured in kilograms, which we abbreviate with kg. And the acceleration, which remembers that change in velocity over time. Is meters per second squared. All right, so an example. What force is needed to accelerate a 3 kilogram cart 2 meters per second squared? So I want it to accelerate at 2 meters per second squared for a time period, and it's 3 kilograms. What force do I need to push it with? So our formula is F equals mass times acceleration. So my mass would be 3. My acceleration would be 2. My force would be 3 times 2. 3 kilograms and 2 meters per second squared. And my answer would be 6 Newton. Cart. Like a buggy, trolley. Does everyone understand how I got that?
Yes, ma'am.
Okay, it's a pretty simple equation. Yes. All right, so if you're to graph this and look at it, when mass is constant, when you have a mass of 5 kg, and we're going to compare the acceleration and the force. We're going to look at those. My acceleration is in meters per second squared. My force down here in newtons. If mass is constant, the more force I apply, what happens to acceleration? If I have a 5 kilogram weight and apply a 2 Newton and it accelerates, and then I apply 4 Newton force, what happens to the acceleration? Does it increase, decrease, or stay the same? Increases. The more force you give, the faster it will accelerate. Alright. When force, there's no T in it, force is constant, so we're still going to put my acceleration on the Y. My mass on the X in kilograms. So, if now I'm going to be applying a 2 Newton force, regardless of the mass, what happens to the acceleration as the mass increases? It decreases. And if you have a small mass, what happens to acceleration? Increases. So you end up with a graph that looks like that. Which just shows that the less mass equals a higher acceleration. And a lower mass has more mass has a lower acceleration. So if you're using the same amount of force and you're pushing something really heavy, you're not going to get as fast an acceleration as you would if you're pushing something light. That, again, that makes conceptual sense. You know that.
I say lower pace?
Lower acceleration.
Acceleration's gonna be, that makes more sense.
Okay, that's right. Okay, all right, remember. So the greater the mass or the acceleration, greater the force. And now we can also use those Star Wars jokes like, "Oh, may the force be with you." Yay! I'm excited about them. I can't talk to you anymore.
There's no understanding, you just gotta watch it. You can't just understand something you don't see. Sorry. I feel so smart now.
Yeah, he's not lying. So, did you know mass is, that's a cursive S with a non-cursive Y there. That's what that is. Mass is a measurement of inertia. Because you know, if I were to apply 5 Newton force to a 2 kilogram versus a 20 kilogram, that the acceleration is going to be a lot less for the 20. This is pretty simple stuff. Go ahead and pull out the other paper I gave you. I was super nice and allowed your formula to be manipulated for you. I will not do that on the test. Your formula is F equals ma. You can move around the M or the A or the F as you need to. You know how to do that. But for this one, look how nice I was. Oh, force. Mass equals acceleration equals force equals. So there are a bunch of problems on here, but this is not a hard formula. You have more than enough time to finish this. Yes.